Welcome to Sparx Science for Sleep, where the mysteries of the universe unfold like a gentle lullaby, guiding you into a world of wonder and rest. I'm so glad you're here, perhaps nestled in soft blankets, or maybe curled up with a cozy pillow, ready to drift into a peaceful journey. Tonight, we'll explore the question that has whispered through the ages. How did everything start from nothing? It's a question that feels like a soft breeze, stirring curiosity while inviting calm. Take a slow, deep breath. Let your shoulders relax, and imagine yourself floating in a quiet, endless space where the universe is about to share its secrets. If you'd like, drop a comment below to tell me where you're listening from or what time it is in your corner of the night. Now, settle in, and let's begin with the whisper of nothingness, a story that starts before the stars were born. Picture yourself adrift in a vast, quiet void, a place so still it feels like the universe is holding its breath. This is the nothingness we're talking about, but it's not empty in the way you might think. In the world of quantum physics, what seems like nothing is alive with possibility, a shimmering sea of energy that hums softly in the background of existence. Scientists call this the quantum vacuum, a place where the rules of the everyday world don't apply. Imagine it as an ocean, not of water, but of tiny flickers of light, where particles pop into being and vanish again, like fireflies blinking in the night. These are virtual particles, fleeting sparks of matter and antimatter, borrowing energy from the universe for just a moment before returning it. Close your eyes and feel yourself floating in this ocean, weightless, surrounded by the gentle dance of these invisible specks. They're not here to stay, but their brief existence tells us something profound. Even in nothing, there's something waiting to be born. This quantum vacuum is a canvas of potential, a place where the laws of physics allow for surprises. Scientists discovered this through experiments, peering into the subatomic world with tools so precise they can catch the faintest whispers of these particles. They found that even in the emptiest space, energy fluctuates, creating ripples that defy our usual ideas of empty. It's as if the universe is a quiet symphony, playing notes too soft for us to hear, yet full of life. These fluctuations are governed by something called the Heisenberg uncertainty principle, a beautiful idea that says we can never know everything about a particle at once. Imagine trying to catch a dream as it slips through your fingers. The more you grasp at one part, the less you know about another. This uncertainty lets particles flicker in and out of existence, a reminder that nothingness is never truly still. As you breathe slowly, let this idea wrap around you like a warm blanket, comforting in its mystery. These fleeting particles aren't just a quirk of physics, they're a clue to how the universe might have begun. Scientists believe that long ago, before time or space as we know them, something like these quantum fluctuations could have set the stage for everything. Picture a single spark in this vast, shimmering void, a tiny ripple that grew into the cosmos. It's a thought that feels both grand and soothing, like watching waves lap gently at the shore. The quantum vacuum isn't a barren place. It's a cradle of creation, where the seeds of stars and galaxies were first sown. As you rest here, imagine yourself cradled too, held by the same universe that turned nothing into everything. Let your breath slow, matching the rhythm of those ancient flickers, each one a whisper of possibility. Feel the calm of knowing that even in the quietest moments, the universe is alive with potential. This idea of nothingness teeming with life is a gift from science, uncovered through years of patient study. Researchers use mathematics and experiments to explore this hidden world, piecing together the puzzle of existence. They found that these quantum fluctuations can affect real things, like the energy levels of atoms, shifting them ever so slightly, like a breeze nudging a leaf. It's a reminder that the universe is always moving, always creating, even in its quietest corners. As you lie there, let this thought settle over you like a soft glow, easing your mind. You don't need to understand every detail. Just let the wonder of it carry you, like a gentle current pulling you towards sleep. The universe began in a place like this, a place of infinite possibility, and you're part of that story, connected to its very beginning. Now, as you drift in this shimmering sea of nothingness, let your thoughts soften, your worries fade like distant stars. Take another slow breath, and feel the quiet beauty of this moment. The universe started with a whisper, a flicker of possibility that grew into everything we know, and from this quiet, magical nothingness, something incredible was about to happen. Let your mind glide forward, ready to explore the next chapter of this cosmic tale, where a single spark lights up the dark and the universe begins to sing. Welcome back to Sparx Science for Sleep, where we drift through the gentle mysteries of the universe, letting each story cradle us toward rest. As we glide from the ancient whispers of the Earth's rocky pages, where time has etched its secrets, we now turn to a new chapter, one filled with the delicate traces of life long gone. Picture a quiet museum, its shelves lined with fossils, each one a frozen moment from a world so distant it feels like a dream. These are the fossils, the marvelous relics of ancient life, that hold clues to whether another civilization might have walked the Earth millions of years before us. Let's take a slow breath and step into this gallery of the past, where the Silurian Hypothesis invites us to wonder about the lives that came before. Fossils are like letters from the Earth, written in stone, telling tales of creatures that swam, crawled, or soared long before humans ever gazed at the stars. In the science of paleontology, these relics are studied with care, pieced together like fragments of a forgotten story. Imagine a trilobite, its segmented shell curled like a tiny scroll, preserved in the rock for over 500 million years. These creatures, with their intricate, jewel-like eyes, thrived in ancient oceans, leaving behind imprints that scientists now hold like treasures. Paleontologists use tools like brushes and microscopes to uncover these fossils, each one a snapshot of life from a time when the Earth was young. The Silurian Hypothesis asks us to look deeper, to wonder if among these relics we might find something stranger, something that hints at a civilization far older than our own. What makes fossils so captivating is their ability to speak across eons. They form when a creature's remains, or even its footprints, are buried in sediment, slowly turning to stone as minerals seep in, like ink soaking into paper. Over millions of years, these remains are locked away in layers of rock, waiting for someone to find them. Scientists have uncovered fossils of ancient fish, their scales shimmering in stone, and dinosaurs, their massive bones telling of a world ruled by giants. But the Silurian Hypothesis pushes us to imagine something more a fossil, not of bone or shell, but of something crafted, something that doesn't fit the usual patterns of nature. Could there be a fossilized tool, a fragment of metal, or a structure so unusual it suggests a thinking mind? As we linger here, picture these fossils glowing softly in the dark, each one a whisper from a lost world. The search for such extraordinary fossils is a delicate dance between science and imagination. Paleontologists scour cliffs, quarries, and riverbeds, looking for clues that might rewrite history. They found fossils that puzzle them, like strange, symmetrical structures from the Precambrian era over 540 million years ago that look almost too perfect to be natural. These are called Ediacaran biota, soft-bodied creatures that resemble nothing we know today, their forms like delicate lace pressed into stone. Could some of these be traces of an ancient technology, mistaken for natural forms? The Silurian Hypothesis suggests we keep an open mind, looking for patterns that don't quite belong, like a fossilized circuit or a shard of something metallic, buried in the Earth's ancient layers. It's a thought that feels like a gentle breeze, stirring curiosity without disturbing the calm. To find these clues, scientists use more than just shovels and brushes. They employ radiometric dating, a method that measures the decay of radioactive elements in rocks to determine their age. Imagine a clock ticking inside the Earth, each decay a second passing over millions of years. This technique has helped date fossils from the Cambrian period, about 540 million years ago, when life exploded in diversity. But what if, among these ancient relics, there's something that doesn't fit a fossil with a composition that suggests it was made, not grown? Scientists have found oddities, like tiny structures in ancient rocks that resemble microscopic machines, though most agree these are likely natural formations. Still, the Silurian Hypothesis invites us to wonder if a civilization's tools could have been fossilized, preserved, like the shells of ancient sea creatures. The Earth is a patient keeper of secrets, but it's not always kind to its relics. Fossilization is rare, requiring just the right conditions, quick burial, the right minerals, and protection from erosion. Most creatures that ever lived left no trace, their bodies dissolving into the Earth's embrace. If an ancient civilization existed, its artifacts might have been ground to dust by time, or they might be hidden in places we haven't yet looked. Scientists estimate that only a tiny fraction of life becomes fossilized, like a single page saved from a burning book. This makes the search for evidence of a Silurian civilization a challenge, like finding a single star in a daytime sky. Yet paleontologists keep searching, driven by the possibility that one fossil could change everything we know about our planet's past. Some fossils spark more questions than answers. Take the Burgess Shale, a deposit in Canada from about 508 million years ago, filled with creatures so strange they seem to belong to another world. These fossils, preserved in exquisite detail, show animals with bizarre appendages and body plans, like nothing alive today. Scientists study these with microscopes and scans, piecing together their lives like a puzzle. The Silurian Hypothesis asks us to consider if some fossils might not be animals at all, but remnants of a civilization's creations, perhaps a tool or a fragment of something engineered. While no such fossil has been confirmed, the idea lingers, like a melody you can't quite place, inviting us to look closer at the Earth's ancient gallery. The study of fossils isn't just about digging, it's about understanding the story of life itself. Paleontologists use chemical analysis to probe the composition of fossils, looking for traces of organic material or unusual elements. Sometimes, they find anomalies, like high levels of carbon or metals in rocks that don't quite match their surroundings. These could be natural, formed by ancient volcanoes or microbial life. But the Silurian Hypothesis suggests another possibility. What if these are traces of industry, of a civilization that burned fuels or crafted materials? Imagine a fossilized fragment, not of bone, but of a substance forged in a long-forgotten workshop, its edges smoothed by time, but still whispering of its makers. The Earth's history is vast, stretching back over 4 billion years, and fossils are only one part of its tale. Most of what we find comes from the last 600 million years, when life began to leave clearer marks. Before that, the rock record is sparse, eroded by wind and water, like a story with missing chapters. If a civilization existed millions of years ago, its fossils might be buried deep, in layers we haven't yet reached, or destroyed by the Earth's restless movements. Scientists use computer models to simulate how artifacts might survive, calculating how metals or plastics would degrade over millions of years. These models suggest that some materials, like certain alloys, could leave faint traces, like ghosts in the stone, waiting for the right eyes to see them. The Silurian Hypothesis also draws on the study of mass extinctions, moments when life on Earth was nearly erased. Fossils from these times, like the boundary between the Permian and Triassic periods about 250 million years ago, show sudden shifts in the types of creatures preserved. Could such an event have wiped out a civilization, leaving only scattered clues? Scientists look for patterns in the fossil record, like sudden changes in sediment or unusual concentrations of elements, that might hint at something more than natural processes. It's a search that feels like wandering through a vast library, where most of the books have crumbled, but a single page might hold a revelation. Fossils also tell us about the environments of the past, painting pictures of ancient oceans, forests, and deserts. By studying the rocks around fossils, scientists reconstruct what the Earth was like millions of years ago, its climate, its atmosphere, its seas. If a civilization existed, it might have altered its environment, leaving traces in the fossil record, like a spike in carbon from burning fuels, or a layer of sediment rich in strange minerals. These clues would be subtle, like a whisper in a storm, but scientists are trained to listen for them, using tools like mass spectrometry to detect the faintest echoes of the past. As we linger in this quiet museum of fossils, the idea of a lost civilization feels like a gentle hum, a possibility that doesn't demand answers, only wonder. The search for such fossils isn't just about finding objects, it's about asking what counts as life. The Silurian Hypothesis challenges us to think beyond bones and shells, to imagine fossils of structures or machines. Scientists have found natural formations, like stromatolites, built by ancient microbes, that look almost engineered in their precision. Could a civilization's creations be mistaken for such natural forms? This question drives researchers to explore new sites, from ancient seabeds to mountain ranges, hoping to uncover something that doesn't fit. It's a quest that feels like chasing a shadow, but each fossil they find adds a new stroke to the Earth's portrait, a canvas that holds more secrets than we can imagine. As we move through this gallery of ancient relics, the Silurian Hypothesis invites us to see fossils not just as remnants of life, but as possible echoes of intelligence. Scientists continue to dig, to analyze, to question, using every tool at their disposal to uncover the Earth's hidden stories. They study fossils from the Devonian period, about 400 million years ago, when life was transitioning from sea to land, wondering if something more complex could have existed. The fossil record is incomplete, like a book with pages torn out, but each discovery brings us closer to understanding the full story of our planet. For now, these marvelous fossils remain whispers of possibility, each one a clue to a past we're only beginning to explore. From this quiet museum of stone and memory, let's drift gently forward to a new chapter where the Earth's chemistry tells its own tale. Imagine the ground beneath you, humming with secrets, its elements holding clues to a world long gone. As we move on, we'll explore how the very atoms in the Earth's crust might reveal the presence of a forgotten civilization, their story written not in stone, but in the subtle music of isotopes. Welcome back to Sparx Science for Sleep, where we drift through the gentle mysteries of the universe, letting each story cradle us toward rest. As we glide from the ancient whispers of the Earth's rocky pages, where time has etched its secrets, we now turn to a new chapter, one filled with the delicate traces of life long gone. Picture a quiet museum, its shelves lined with fossils, each one a frozen moment from a world so distant it feels like a dream. These are the fossils, the marvelous relics of ancient life that hold clues to whether another civilization might have walked the Earth millions of years before us. Let's take a slow breath and step into this gallery of the past, where the Silurian Hypothesis invites us to wonder about the lives that came before. Fossils are like letters from the Earth, written in stone, telling tales of creatures that swam, crawled, or soared long before humans ever gazed at the stars. In the science of paleontology, these relics are studied with care, pieced together like fragments of a forgotten story. Imagine a trilobite, its segmented shell curled like a tiny scroll, preserved in the rock for over 500 million years. These creatures, with their intricate jewel-like eyes, thrived in ancient oceans, leaving behind imprints that scientists now hold like treasures. Paleontologists use tools like brushes and microscopes to uncover these fossils, each one a snapshot of life from a time when the Earth was young. The Silurian Hypothesis asks us to look deeper, to wonder if among these relics we might find something stranger, something that hints at a civilization far older than our own. What makes fossils so captivating is their ability to speak across eons. They form when a creature's remains, or even its footprints, are buried in sediment, slowly turning to stone as minerals seep in, like ink soaking into paper. Over millions of years, these remains are locked away in layers of rock, waiting for someone to find them. Scientists have uncovered fossils of ancient fish, their scales shimmering in stone, and dinosaurs, their massive bones telling of a world ruled by giants. But the Silurian Hypothesis pushes us to imagine something more of fossil, not of bone or shell, but of something crafted, something that doesn't fit the usual patterns of nature. Could there be a fossilized tool, a fragment of metal, or a structure so unusual it suggests a thinking mind? As we linger here, picture these fossils glowing softly in the dark, each one a whisper from a lost world. The search for such extraordinary fossils is a delicate dance between science and imagination. Paleontologists scour cliffs, quarries, and riverbeds, looking for clues that might rewrite history. They've found fossils that puzzle them, like strange, symmetrical structures from the Precambrian era, over 540 million years ago, that look almost too perfect to be natural. These are called Ediacaran biota, soft-bodied creatures that resemble nothing we know today, their forms like delicate lace pressed into stone. Could some of these be traces of an ancient technology, mistaken for natural forms? The Silurian Hypothesis suggests we keep an open mind, looking for patterns that don't quite belong, like a fossilized circuit or a shard of something metallic buried in the Earth's ancient layers. It's a thought that feels like a gentle breeze, stirring curiosity without disturbing the calm. To find these clues, scientists use more than just shovels and brushes. They employ radiometric dating, a method that measures the decay of radioactive elements in rocks to determine their age. Imagine a clock ticking inside the Earth, each decay a second passing over millions of years. This technique has helped date fossils from the Cambrian period, about 540 million years ago, when life exploded in diversity. But what if, among these ancient relics, there's something that doesn't fit a fossil with a composition that suggests it was made, not grown? Scientists have found oddities, like tiny structures in ancient rocks that resemble microscopic machines, though most agree these are likely natural formations. Still, the Silurian Hypothesis invites us to wonder if a civilization's tools could have been fossilized, preserved like the shells of ancient sea creatures. The Earth is a patient keeper of secrets, but it's not always kind to its relics. Fossilization is rare, requiring just the right conditions, quick burial, the right minerals, and protection from erosion. Most creatures that ever lived left no trace, their bodies dissolving into the Earth's embrace. If an ancient civilization existed, its artifacts might have been ground to dust by time, or they might be hidden in places we haven't yet looked. Scientists estimate that only a tiny fraction of life becomes fossilized, like a single page saved from a burning book. This makes the search for evidence of a Silurian civilization a challenge, like finding a single star in a daytime sky. Yet paleontologists keep searching, driven by the possibility that one fossil could change everything we know about our planet's past. Some fossils spark more questions than answers. Take the Burgess Shale, a deposit in Canada from about 508 million years ago, filled with creatures so strange they seem to belong to another world. These fossils, preserved in exquisite detail, show animals with bizarre appendages and body plans, like nothing alive today. Scientists study these with microscopes and scans, piecing together their lives like a puzzle. The Silurian Hypothesis asks us to consider if some fossils might not be animals at all, but remnants of a civilization's creations, perhaps a tool or a fragment of something engineered. While no such fossil has been confirmed, the idea lingers, like a melody you can't quite place, inviting us to look closer at the Earth's ancient gallery. The study of fossils isn't just about digging, it's about understanding the story of life itself. Paleontologists use chemical analysis to probe the composition of fossils, looking for traces of organic material or unusual elements. Sometimes they find anomalies, like high levels of carbon or metals in rocks that don't quite match their surroundings. These could be natural, formed by ancient volcanoes or microbial life, but the Silurian Hypothesis suggests another possibility. What if these are traces of industry, of a civilization that burned fuels or crafted materials? Imagine a fossilized fragment, not of bone, but of a substance forged in a long-forgotten workshop, its edges smoothed by time but still whispering of its makers. The Earth's history is vast, stretching back over 4 billion years, and fossils are only one part of its tale. Most of what we find comes from the last 600 million years, when life began to leave clearer marks. Before that, the rock record is sparse, eroded by wind and water, like a story with missing chapters. If a civilization existed millions of years ago, its fossils might be buried deep, in layers we haven't yet reached, or destroyed by the Earth's restless movements. Scientists use computer models to simulate how artifacts might survive, calculating how metals or plastics would degrade over millions of years. These models suggest that some materials, like certain alloys, could leave faint traces, like ghosts in the stone, waiting for the right eyes to see them. The Silurian Hypothesis also draws on the study of mass extinctions, moments when life on Earth was nearly erased. Fossils from these times, like the boundary between the Permian and Triassic periods about 250 million years ago, show sudden shifts in the types of creatures preserved. Could such an event have wiped out a civilization, leaving only scattered clues? Scientists look for patterns in the fossil record, like sudden changes in sediment or unusual concentrations of elements, that might hint at something more than natural processes. It's a search that feels like wandering through a vast library where most of the books have crumbled, but a single page might hold a revelation. Fossils also tell us about the environments of the past, painting pictures of ancient oceans, forests, and deserts. By studying the rocks around fossils, scientists reconstruct what the Earth was like millions of years ago, its climate, its atmosphere, its seas. If a civilization existed, it might have altered its environment, leaving traces in the fossil record, like a spike in carbon from burning fuels or a layer of sediment rich in strange minerals. These clues would be subtle, like a whisper in a storm, but scientists are trained to listen for them, using tools like mass spectrometry to detect the faintest echoes of the past. As we linger in this quiet museum of fossils, the idea of a lost civilization feels like a gentle hum, a possibility that doesn't demand answers, only wonder. The search for such fossils isn't just about finding objects. It's about asking what counts as life. The Silurian Hypothesis challenges us to think beyond bones and shells, to imagine fossils of structures or machines. Scientists have found natural formations, like stromatolites, built by ancient microbes, that look almost engineered in their precision. Could a civilization's creations be mistaken for such natural forms? This question drives researchers to explore new sites, from ancient seabeds to mountain ranges, hoping to uncover something that doesn't fit. It's a quest that feels like chasing a shadow, but each fossil they find adds a new stroke to the Earth's portrait, a canvas that holds more secrets than we can imagine. As we move through this gallery of ancient relics, the Silurian Hypothesis invites us to see fossils not just as remnants of life, but as possible echoes of intelligence. Scientists continue to dig, to analyze, to question, using every tool at their disposal to uncover the Earth's hidden stories. They study fossils from the Devonian period, about 400 million years ago, when life was transitioning from sea to land, wondering if something more complex could have existed. The fossil record is incomplete, like a book with pages torn out, but each discovery brings us closer to understanding the full story of our planet. For now, these marvelous fossils remain whispers of possibility, each one a clue to a past we're only beginning to explore. From this quiet museum of stone and memory, let's drift gently forward to a new chapter where the Earth's chemistry tells its own tale. Imagine the ground beneath you humming with secrets, its elements holding clues to a world long gone. As we move on, we'll explore how the very atoms in the Earth's crust might reveal the presence of a forgotten civilization, their story written not in stone, but in the subtle music of isotopes. Welcome back to Sparx Science for Sleep, where we wander through the quiet mysteries of the Earth, letting each discovery lull us into a gentle calm. As we step away from the glowing fossils, those ancient relics whispering tales of forgotten lives, we now turn to the subtle music of the Earth's chemistry. Imagine the ground beneath you as a vast orchestra, each atom playing a note in a symphony that stretches back millions of years. The Silurian Hypothesis invites us to listen closely, to hear if the Earth's elements might sing of a civilization long vanished, their story etched not in stone, but in the delicate balance of isotopes. Let's take a soft breath and drift into this world of chemical whispers, where the past hums with secrets waiting to be uncovered. The Earth's crust is a tapestry woven from atoms, each one carrying a story of where it came from and what it has seen. In the science of geochemistry, researchers study these atoms, particularly isotopes, which are like siblings of the same element with slightly different weights. Picture a carbon atom, light and nimble, with 6 protons but varying numbers of neutrons, some with 6, others with 8. These differences, subtle as a breeze, can reveal profound truths. Scientists use isotopes to trace the history of the Earth, like following footprints through time. If an ancient civilization existed, as the Silurian Hypothesis suggests, it might have left chemical signatures unusual ratios of isotopes in the rocks, hinting at activities like burning fuels or crafting materials. Imagine these signatures as faint echoes, preserved in the Earth's memory, waiting for a curious mind to find them. Isotopes form through natural processes, like the decay of radioactive elements deep within the planet, or the fusion of atoms in the hearts of ancient stars. Scientists measure their ratios using tools like mass spectrometers, machines that sort atoms by weight with the precision of a librarian cataloguing books. For example, carbon isotopes, known as carbon-12 and carbon-13, exist in predictable ratios in nature. But if a civilization burned vast amounts of fuel, like coal or oil, it could shift these ratios, leaving a spike of lighter carbon in the rock record. Such a spike was found in rocks from the end of the Permian period, about 250 million years ago, though scientists attribute it to volcanic activity. The Silurian hypothesis asks us to consider another possibility. Could such a signal come from a civilization's industry, its fires burning brightly millions of years ago? This chemical detective work is like listening to a song played on an ancient instrument, its notes faint but clear to those who know how to hear. Scientists look for anomalies in other elements too, like nitrogen or sulfur, which could suggest industrial processes. Imagine a civilization crafting metals, smelting ores in furnaces, releasing sulfur into the air. Over time, this could leave a layer of rock enriched with unusual isotopes, like a signature scrawled across the Earth's history. Researchers have found such anomalies in rocks from the Devonian period, about 400 million years ago, where nitrogen isotopes hint at changes in the atmosphere. While these are likely due to natural shifts, like changes in ocean life, the Silurian hypothesis whispers a question. What if some of these signals came from a civilization's hand, its work etched into the Earth's chemical code? The beauty of isotopes lies in their longevity, their ability to hold a story for millions of years. Unlike fossils, which can erode or break, isotopes are woven into the very structure of rocks, like secrets locked in a vault. Scientists study samples from ancient lake beds, ocean floors, or even the ash of long-dead volcanoes, looking for patterns that stand out. One clue might be a sudden increase in heavy metals, like lead or uranium, which could suggest mining or manufacturing. In modern times, human industry leaves such marks on nuclear tests of scattered isotopes like cesium-137 across the globe. If a Silurian civilization existed, it might have left similar traces, a chemical fingerprint of its existence, faint but enduring, like a melody that lingers in the air. To uncover these clues, scientists use techniques like isotopic fractionation, where they analyze how isotopes separate based on their weight during natural processes. Picture water evaporating from an ancient sea, leaving heavier isotopes behind in the salt. If a civilization altered its environment, say, by diverting rivers or building cities, it could disrupt these natural patterns, leaving a signal in the rocks. Researchers have found such disruptions in layers from the Cretaceous period, about 66 million years ago, tied to the asteroid impact that ended the dinosaurs. But the Silurian hypothesis encourages us to look deeper, to wonder if earlier disruptions, perhaps from 400 million years ago, could point to something more deliberate, like a civilization reshaping its world. The Earth's chemistry is a vast archive, preserving not just the story of life, but the possibility of industry. Scientists study carbon cycles, the way carbon moves between air, water, and rock, to understand ancient climates. A sudden spike in carbon dioxide, like the one we see in our own time from burning fossil fuels, could have happened millions of years ago if a civilization relied on similar energy sources. Such a spike was detected in rocks from the Paleocene-Eocene thermal maximum, about 55 million years ago, when the Earth warmed dramatically. While this is thought to be natural, caused by volcanic eruptions, the Silurian hypothesis asks us to imagine a different cause, a civilization's factories humming, their emissions captured in the stone like a breath held for eons. This search for chemical clues isn't just about isotopes, it's about understanding how a civilization might have changed the Earth's surface. Imagine a city built of stone and metal, its structures crumbling over millions of years. The materials concrete, steel, or even plastics would break down, but their chemical components could linger. Plastics, for example, might degrade into microscopic particles, mixing with sediments to form unusual layers. Scientists have found strange carbon compounds in ancient rocks, often linked to microbial activity, but the Silurian hypothesis suggests we consider if some could be remnants of synthetic materials, crafted by hands or minds long gone. It's a thought that feels like a whisper from the deep past, inviting us to listen more closely to the Earth's chemical song. The The challenge of finding these signals lies in the Earth's restless nature. Over millions of years, tectonic plates shift, mountains rise and erode, and oceans reshape the land. What was once a bustling city could be ground to dust or buried beneath miles of rock. Scientists use isotopic analysis to peer through this chaos, looking for patterns that don't align with natural processes. For instance, high levels of iridium, a rare metal, were found in rocks from the Cretaceous-Paleogene boundary, pointing to an asteroid impact. Could a similar anomaly, perhaps from a different time, suggest a civilization's technology? The Silurian Hypothesis pushes us to explore this, to see the Earth's chemistry as a canvas where a forgotten civilization might have left its mark. Geochemists also study trace elements, like rare earth metals, which could hint at advanced technology. These metals, used in modern electronics, are rare in nature but can concentrate in specific conditions. If a civilization mined or processed them, they might leave a spike in the rock record, like a flare in the dark. Scientists have found such spikes in ancient sediments, often tied to volcanic activity or asteroid impacts. But the Silurian Hypothesis asks us to consider another source, a civilization's industry, its tools and machines leaving a chemical legacy. Imagine a layer of rock glowing faintly with these elements, telling a story of a world that thrived millions of years before our own. This chemical exploration is a journey through time, guided by the tools of modern science. Mass spectrometry, for instance, lets researchers measure isotopic ratios with astonishing precision, like reading the fine print of the Earth's history. They've used it to study rocks from the Silurian period itself, about 430 million years ago, looking for signs of unusual activity. While no clear evidence of a civilization has been found, the search continues, driven by the possibility that a single anomaly could rewrite our understanding. It's like searching for a lost melody in a vast symphony, each note a clue to a world we can only imagine. The Earth's chemical record is also shaped by its atmosphere, which interacts with rocks and water over millions of years. A civilization burning fuels or releasing pollutants could alter this balance, leaving traces in the form of isotopic shifts. Scientists have found such shifts in rocks from the Devonian, where changes in oxygen isotopes suggest shifts in climate or ocean chemistry. While these are likely natural, the Silurian Hypothesis encourages us to ask if some could be artificial, the result of a civilization's impact on its world. Picture a factory's smoke rising into an ancient sky, its chemical signature settling into the earth, preserved like a memory in amber. This idea of a chemical legacy extends to the oceans, where sediments capture the history of the water above. If a civilization altered its environment, say, by mining or agriculture, it could leave traces in the form of unusual isotope ratios or elevated levels of certain elements. Scientists study ocean sediments from millions of years ago, looking for patterns that stand out, like a note played out of tune. They've found anomalies in carbon and sulfur isotopes from the Silurian period, often linked to changes in marine life, but the possibility of a civilization's influence lingers, like a shadow in the water. It's a thought that adds depth to the Earth's story, making each rock a potential messenger from the past. The Silurian Hypothesis also draws on the study of anthropogenic signals marks left by human activity in our own time. For example, modern industry has left traces like increased carbon dioxide or radioactive isotopes from nuclear tests. If a civilization existed millions of years ago, it might have left similar signals, now faded but still detectable. Scientists use these modern analogues to guide their search, imagining how a Silurian civilization's activities might mirror our own. It's like looking at our reflection in a very old mirror, the image blurred but still recognizable, hinting at a world that might have been. As we drift through this chemical symphony, the Earth's atoms sing of a past vast and deep. Scientists continue to probe these signals, using every tool at their disposal to uncover the truth. They study rocks from every corner of the globe, from ancient deserts to frozen mountains, searching for that one anomaly that could change everything. The Silurian Hypothesis is a reminder that the Earth is a living archive, its chemistry, a record of all that has come before. For now, these isotopic notes remain a quiet hum, a possibility that invites us to keep listening, to keep wondering. From this gentle melody of isotopes, let's glide into the next chapter of our journey, where the Earth's dramatic moments take center stage. Imagine the planet as an artist, painting its history with fire and stone, erasing some stories while preserving others. We'll explore how great cataclysms, like asteroids and volcanoes, might have hidden or revealed the traces of a lost civilization, their power shaping the Earth's tale in ways we're only beginning to understand. Welcome back to Sparx Science for Sleep, where we drift through the Earth's ancient tales, each one a soothing whisper from the past. As we leave behind the delicate notes of the planet's chemical symphony, where isotopes sang of forgotten activities, we now step into a grander, more dramatic chapter. Picture the Earth as a vast canvas, painted with fire and stone, where colossal events have sculpted its history. The Silurian Hypothesis invites us to explore how cataclysms, like crashing asteroids or erupting volcanoes, might have erased or preserved the traces of a civilization that walked the Earth millions of years ago. Let's take a gentle breath and wander into this story of destruction and creation, where the planet's upheavals hold secrets as deep as the night. The Earth is a restless artist, reshaping itself through events so powerful they can rewrite the story of life. Scientists call these mass extinctions, moments when the planet's surface was transformed by forces beyond imagination. One of the most famous happened 66 million years ago, when an asteroid, wider than a city, slammed into what is now Mexico's Yucatan Peninsula. This impact, known as the Chicxulub event, sent shockwaves through the Earth, igniting fires, triggering tsunamis, and blanketing the skies with dust that blocked the sun. Dinosaurs, once rulers of the world, vanished, leaving only their bones in the rock. The Silurian Hypothesis asks us to consider if a similar catastrophe could have erased an ancient civilization, its cities and tools buried or obliterated by such a cataclysm, their story lost in the ashes of time. These events are like the Earth hitting a reset button, reshaping ecosystems and leaving clues in the geological record. The Chicxulub asteroid left a thin layer of iridium, a metal rare on Earth but common in space rocks, stretched across the globe. Scientists found this layer in rocks from the Cretaceous-Paleogene boundary, a marker of the disaster that ended an era. If a civilization existed hundreds of millions of years ago, perhaps in the Silurian period, around 430 million years ago, a similar event could have buried its remains. Imagine a bustling society, its structures of stone or metal, swallowed by a flood of molten rock or crushed beneath falling ash. The evidence might still be there, hidden in a layer of sediment, waiting for a scientist's careful hand to uncover it. Volcanoes, too, have played a starring role in the Earth's dramatic history. Around 250 million years ago, the Siberian Traps, a vast region of volcanic rock, erupted for thousands of years, spewing lava and gases across what is now Russia. This event, tied to the Permian-Triassic extinction, wiped out nearly 90% of life on Earth. The skies darkened, the climate shifted, and the oceans turned toxic. Scientists study the rocks from this time, finding layers of ash and basalt that tell of a world in chaos. The Silurian Hypothesis suggests that a similar volcanic upheaval could have erased a civilization's traces, melting their creations or burying them under miles of hardened lava, like a painting covered by a new coat of color. These cataclysms don't just destroy, they also preserve. The same forces that shatter can entomb, locking evidence in the Earth's embrace. When an asteroid strikes, it can create craters that fill with sediment, preserving whatever lies beneath. Scientists have found fossils from the moments after the Chicxulub impact, fish frozen in time with debris still falling around them. If a civilization's artifacts, say, a tool or a piece of machinery, were caught in such an event, they could be sealed in sediment, like a letter sealed in wax. The Silurian Hypothesis encourages us to look for such moments, where the Earth's fury might have preserved a fragment of a lost world, perhaps in rocks from 400 million years ago, when the planet was lush with ancient seas. The Earth's surface is a battleground of time, where erosion and tectonic shifts grind away the past. Most traces of life, let alone a civilization, are worn down by wind, rain, and the slow churn of continents. Scientists estimate that only a tiny fraction of the Earth's history survives in the rock record, like a book with most of its pages torn out. If a civilization existed, its buildings or machines might have been pulverized by these forces, leaving only faint clues. Yet some environments, like ancient lakebeds or coastal plains, can act as time capsules. Researchers study these places, drilling into the earth to find layers that might hold unusual materials, perhaps a spike in metals or carbon that doesn't match the natural record, hinting at a civilization's hand. Mass extinctions leave distinct signatures, like scars on the Earth's skin. Scientists look for sudden changes in the rock layers, such as shifts in fossil types or chemical composition. The Permian-Triassic extinction, for instance, shows a dramatic drop in marine fossils and a surge in carbon isotopes, suggesting a collapse of ecosystems. The Silurian Hypothesis asks us to imagine a similar signature, but from an artificial source, a civilization's pollution or industry altering the planet's chemistry. Picture a city's smokestacks releasing gases, their imprint captured in a layer of rock, now buried deep beneath a mountain. Scientists use tools like isotopic analysis to detect these anomalies, searching for patterns that stand out like a single off-key note in a quiet melody. The Earth's cataclysms are not just destructive, they're part of its cycle of renewal. After each extinction, life rebounds, filling the world with new forms. Following the Permian-Triassic event, reptiles and early mammals emerged, reshaping the planet's ecosystems. If a civilization was wiped out by such an event, its remnants might be mixed with these new layers of life, hidden among the fossils of creatures that rose in its wake. Scientists study these transitions, looking for clues that don't fit, perhaps a shard of material too regular to be natural, or a chemical signal that suggests something more than volcanic ash. The Silurian Hypothesis invites us to see these moments as opportunities, where the Earth's upheavals might have preserved a civilization's legacy in unexpected ways. Asteroid impacts, in particular, are like cosmic punctuation marks, ending one chapter of Earth's story and starting another. The Chicxulub crater, over 90 miles wide, is a testament to the power of these events. Scientists have drilled into its depths, finding rocks that tell of a world turned upside down. If a Silurian civilization existed, an impact like this could have buried its cities under layers of debris, preserving them like a snapshot in time. Researchers use seismic imaging to map these craters, revealing structures beneath the surface that might hold clues. Imagine a fragment of a wall or a tool, locked in sediment, its edges worn but still whispering of its makers, waiting for a scientist to find it. Volcanic eruptions, too, can act as both destroyers and archivists. The Siberian Traps left behind vast fields of basalt, but within these rocks, scientists find tiny inclusions, minerals or gases trapped during the eruptions. These can hold clues to the environment at the time, like a diary entry from a world in turmoil. If a civilization's activities altered the air or water, their signature might be trapped in these inclusions, perhaps a spike in sulfur or heavy metals. The Silurian Hypothesis encourages us to look for such signals, especially in rocks from periods like the Devonian, when the Earth was alive with early forests and seas. It's like searching for a single thread in a vast tapestry, each clue a potential link to a lost world. The Earth's tectonic plates add another layer of complexity to this search. These massive slabs of crust slide and collide, recycling the planet's surface over millions of years. What was once a city could be subducted, pulled deep into the Earth's mantle, or thrust upward into a mountain range. Scientists study these processes, using models to predict where ancient landscapes might have been preserved. If a civilization existed, its remnants might be scattered across these shifting plates, like pieces of a puzzle tossed by the wind. The Silurian Hypothesis asks us to consider that some fragments might survive, perhaps in a fold of rock or a buried valley, waiting to tell their story. The aftermath of cataclysms often creates unique geological features, like impact craters or volcanic ash layers, that scientists use as markers in time. These features can act as bookmarks, helping researchers pinpoint when events occurred. For example, the iridium layer from the Chicxulub impact is a global marker, found from Italy to New Zealand. If a Silurian civilization was erased by a similar event, its traces might be tied to such a marker, perhaps a layer rich in unusual materials. Scientists use radiometric dating to age these layers, measuring the decay of elements like uranium to pin down their timing. It's like reading the Earth's clock, each tick a million years, guiding us to the moments when a civilization might have fallen. These catastrophic events also reshape the planet's climate, leaving clues in the rock record. After the Permian-Triassic extinction, the Earth warmed dramatically, with carbon dioxide levels soaring. Scientists find evidence of this in the form of isotopic shifts and changes in fossilized plants. If a civilization's industry altered the climate, it could leave a similar signal, a sudden change in carbon or oxygen isotopes preserved in ancient sediments. The Silurian Hypothesis suggests we look for these anomalies, perhaps in rocks from 400 million years ago, when the Earth was a mosaic of shallow seas and emerging land. It's like listening for a whisper in the wind, a hint of a world that once was. The power of these cataclysms lies in their ability to both erase and preserve. While they might destroy a civilization's cities, they can also bury evidence deep within the Earth, protecting it from erosion. Scientists study sites like impact craters or volcanic deposits, using tools like core samples to probe the past. These samples, drilled from miles below the surface, can reveal layers untouched by time, like pages in a sealed book. If a Silurian civilization existed, its remnants might be hidden in such a layer, perhaps a fragment of metal or a chemical signature that doesn't belong. The search is painstaking, like finding a single grain of sand on a beach, but each discovery adds to the Earth's story. The Silurian Hypothesis also draws on the study of mass extinction boundaries, where the rock record shows abrupt changes. These boundaries, like the one marking the end of the Devonian period, about 360 million years ago, show shifts in life and chemistry. Scientists look for anomalies here, unusual minerals, strange isotopic ratios, or layers that don't match the expected patterns. If a civilization's technology altered the Earth, its traces might be locked in these boundaries, preserved by the very forces that destroyed it. It's a thought that feels like a quiet hum, a reminder that the Earth's cataclysms are both creators and destroyers, shaping the planet's history in ways we're only beginning to understand. From this dramatic tale of fire and stone, let's drift gently forward to a quieter realm where the Earth's oceans hold their own secrets. Imagine sinking into the deep, where sediments pile up like pages in a vast library, each layer a story from a time long gone. We'll explore how the sea might have preserved the traces of a lost civilization, its treasures hidden in the silent depths, waiting for us to find them. Welcome back to Sparx Science for Sleep, where we drift through the Earth's ancient stories, each one a gentle lullaby from the depths of time. As we rise from the dramatic upheavals of cataclysms, where fire and stone reshaped the planet's history, we now sink into a quieter realm, far beneath the waves. Picture the ocean floor as a vast, silent library, its shelves stacked with layers of sediment, each grain a page in the Earth's endless book. The Silurian Hypothesis invites us to explore these underwater archives, where traces of a long-lost civilization might lie hidden, preserved in the cool embrace of the sea. Let's take a soft breath and glide into this tranquil world, where the deep holds secrets waiting to be uncovered. The ocean is the Earth's greatest keeper of memories, its depths collecting the stories of eons in layers of mud and sand. Scientists call these layers marine sediments, formed as particles settle slowly to the seafloor, like snow falling on a winter night. Over millions of years, these sediments pile up, creating a record of the planet's past, from ancient climates to long-extinct creatures. If a civilization existed hundreds of millions of years ago, as the Silurian Hypothesis suggests, its remnants could be buried here, in the quiet dark of the ocean floor. Imagine a city's debris, shards of metal, fragments of tools, or even synthetic materials sinking into the mud, sealed away by time. Scientists study these sediments, drilling deep into the seabed to retrieve cores that hold clues to a world we can only imagine. These sediment cores are like scrolls, unrolled to reveal the Earth's history. Each layer captures a moment, from the shells of tiny creatures to the dust of distant volcanoes. Scientists use them to reconstruct ancient oceans, tracking changes in temperature, chemistry, or life. If a Silurian civilization altered its environment, perhaps through mining, agriculture, or industry, it might have left traces in these layers, like a faint signature in ink. For example, a sudden spike in heavy metals, like nickel or chromium, could suggest smelting or manufacturing, processes that release unnatural elements into the water. Researchers have found such anomalies in sediments from the Devonian period, about 400 million years ago, though these are often tied to natural events like volcanic eruptions. The Silurian Hypothesis asks us to consider if some could be the work of a civilization, its legacy preserved in the sea's silent embrace. Drilling into the ocean floor is a feat of engineering, like reaching into the past with a careful hand. Scientists use ships equipped with long drills, plunging miles beneath the waves to extract cores of sediment. These cores, sometimes stretching back hundreds of millions of years, are studied in labs with tools like microscopes and chemical analyzers. They've revealed traces of ancient seas, like the warm, shallow waters of the Silurian period, teeming with early fish and coral reefs. If a civilization existed then, its artifacts might have settled into these sediments, perhaps a fragment of something crafted, now mixed with the shells of ancient creatures. It's a thought that feels like a whisper from the deep, a possibility that the ocean holds more than we know. The ocean's depths are not just a graveyard for the past. They're a time capsule, preserving what the surface cannot. Unlike land, where erosion and tectonic shifts grind away history, the seafloor is often stable, its layers undisturbed for eons. Scientists study these sediments to find anomalies, like unusual concentrations of carbon or rare metals, that might hint at a civilization's presence. For instance, modern human activity has left traces in ocean sediments, microplastics, radioactive isotopes from nuclear tests, or spikes in lead from industrial pollution. If a Silurian civilization used similar technologies, their activities could have left parallel marks, like a faint echo in the mud, waiting for a scientist's keen eye to spot it. Another treasure of the deep is found in ice cores, though these are younger, reaching back only a few million years. Drilled from polar ice caps, these cores capture ancient air bubbles, pollen, or dust, offering a snapshot of the Earth's atmosphere. If a civilization altered the air, say, by burning fuels, it might have left a chemical fingerprint, like a spike in carbon dioxide or methane. Scientists have found such spikes in ice cores from the past few 100,000 years, tied to natural climate shifts. The Silurian Hypothesis extends this idea to older times, suggesting that sediments from 400 million years ago might hold similar clues, perhaps a trace of smoke from ancient fires, preserved in the frozen record of the sea. The ocean sediments also preserve the story of life itself through the tiny shells of creatures called foraminifera. These microscopic organisms, with their delicate spiral shells, sink to the seafloor when they die, forming layers that scientists use to date the past. By analyzing their chemistry, researchers can reconstruct ancient ocean conditions, its temperature, acidity, or oxygen levels. If a civilization polluted its waters or mined its resources, it could have altered these conditions, leaving a signal in the foraminifera's shells. Imagine a layer of sediment, glowing with the faint sheen of these shells, holding a clue to a civilization's impact, like a note slipped between the pages of a book. Scientists also look for unusual materials in these sediments, like rare earth elements or synthetic compounds, that could suggest advanced technology. Modern plastics, for example, break down into tiny particles that settle into the seafloor, creating a marker of human presence. If a Silurian civilization used similar materials, perhaps a form of early plastic or alloy, they might have left analogous traces. Researchers have found odd carbon compounds in ancient sediments, often linked to microbial life, but the Silurian Hypothesis asks us to consider if some could be remnants of something crafted, a material not born of nature but of intelligence. It's like finding a single unusual bead in a string of pearls, a hint of something extraordinary. The ocean floor is vast, covering 70% of the Earth, and much of it remains unexplored. Scientists use submersibles and sonar to map its depths, revealing ridges, trenches, and plains where sediments have accumulated for billions of years. Some areas, like the abyssal plains, are like quiet deserts, where sediment settles undisturbed, preserving a pristine record. If a civilization's debris sank to these depths, it could be locked in these layers, untouched by the chaos of the surface. Researchers study cores from such places, looking for anomalies that stand out, like a single off-key note in a gentle melody, suggesting a civilization's hand in the Earth's ancient story. The process of studying these sediments is slow and meticulous, like reading a manuscript in a forgotten language. Scientists slice cores into thin sections, analyzing each for chemical or mineral clues. They found traces of ancient events, like the oxygenation of the oceans around 2 billion years ago, which changed the planet's chemistry forever. If a Silurian civilization altered its environment, its impact might be captured in a similar shift, perhaps a spike in metals or carbon from industrial processes. The challenge is distinguishing these from natural changes, like those caused by volcanic eruptions or shifts in ocean currents. The Silurian Hypothesis encourages us to keep looking, to see the ocean's depths as a treasure trove of possibilities. Ice cores, while younger, offer another window into the past. Drilled from Antarctica or Greenland, they preserve ancient air, trapped in bubbles like tiny time capsules. Scientists analyze these for gases like methane, which can spike during periods of warming or biological activity. If a civilization existed millions of years ago, its activities might have released similar gases, leaving a trace in the sediments of ancient seas. While ice cores don't reach back to the Silurian period, they provide a model for how environmental changes are recorded. Researchers use this to guide their search in older sediments, looking for patterns that might suggest a civilization's influence, like a ripple spreading across a still pond. The ocean's sediments also hold clues to ancient climates, which could reveal a civilization's impact. For example, a sudden warming event, like the Paleocene-Eocene thermal maximum 55 million years ago, left traces in ocean sediments, with shifts in carbon isotopes and microfossils. If a Silurian civilization altered the climate, perhaps through deforestation or burning fuels, it could have left a similar mark, a layer of sediment rich in unusual isotopes. Scientists use mass spectrometry to detect these changes, measuring the tiniest variations in atomic composition. It's like listening to the Earth's heartbeat, each pulse a clue to a world that might have been. The search for these underwater treasures is not just about finding artifacts, it's about understanding the Earth's rhythms. Sediments record cycles of ice ages, ocean currents, and volcanic eruptions, each layer a chapter in the planet's story. If a civilization existed, its activities might have disrupted these cycles, leaving a signal in the sediment record. Scientists look for anomalies, like sudden changes in sediment composition or unusual concentrations of elements, that could suggest something beyond natural processes. The Silurian Hypothesis invites us to see the ocean floor as a vast archive, where a single layer might hold the key to a lost civilization, its story preserved in the quiet depths. The ocean's depths are also shaped by plate tectonics, which can bury or expose sediments over millions of years. In some places, ancient seabeds are thrust upward, forming mountains where scientists can study them. In others, sediments are subducted, pulled into the Earth's mantle, erasing their secrets. If a Silurian civilization's remnants sank to the sea floor, they might be preserved in stable regions, like the deep abyssal plains, or lost to the planet's recycling. Scientists use models to predict where these stable zones might be, guiding their drills to the most promising sites. It's like searching for a hidden vault, its contents locked away by the Earth's slow dance of plates. The study of ocean sediments also reveals the story of ancient ecosystems, from coral reefs to plankton blooms. If a civilization altered these ecosystems, say, through pollution or resource extraction, it could leave traces in the sediment record, like a shadow cast by a long-gone light. Scientists have found such shadows in modern sediments, where industrial activity has left layers rich in pollutants. The Silurian Hypothesis asks us to look for similar signals in older layers, perhaps from the Silurian or Devonian periods, when the Earth was a patchwork of seas and emerging land. It's a search that feels like diving into a dream, where each grain of sediment holds a piece of the past. As we linger in this underwater library, the ocean's depths whisper of a time when the Earth was different, its seas alive with possibility. Scientists continue to explore these sediments, using every tool at their disposal to uncover the truth. They study cores from across the globe, from the Pacific's deep trenches to the Atlantic's quiet plains, searching for that one anomaly that could change everything. The Silurian Hypothesis is a reminder that the ocean is more than a body of water. It's a keeper of secrets, its layers holding stories we're only beginning to read. From this silent archive of the sea, let's glide gently forward to a new chapter, where the tools of modern science shine a light on the past. Imagine a lantern glowing in the dark, illuminating hidden corners of the Earth's history. We'll explore how researchers use technology to hunt for traces of a lost civilization. Their discoveries a bridge between the ancient and the new, guiding us deeper into the planet's timeless tale. Welcome back to Sparx Science for Sleep, where we drift through the Earth's ancient whispers, each tale a soft invitation to rest. As we rise from the silent library of the ocean's depths, where sediments hold the secrets of eons, we now turn to the tools of modern science, shining like lanterns in the dark. These instruments, born of human curiosity, allow us to peer into the past, searching for traces of a civilization that might have walked the Earth millions of years ago. The Silurian Hypothesis beckons us to explore how technology, like a key to a hidden door, might unlock the mysteries of a lost world. Let's take a gentle breath and step into this realm of discovery, where the tools of the future illuminate the shadows of the past. The Earth is a vast puzzle, its pieces scattered across time, and scientists use an array of ingenious tools to piece it together. One such tool is ground-penetrating radar, a device that sends waves into the ground, like echoes bouncing through a quiet cave. These waves reflect off buried structures, revealing shapes hidden beneath the soil. Imagine a city from 400 million years ago, its foundations buried under layers of rock. Ground-penetrating radar could detect anomalies, perhaps the outline of a wall or a road where natural formations wouldn't exist. Scientists have used this technology to uncover ancient human sites, like the stone circles of Stonehenge, mapping their contours without digging. The Silurian Hypothesis asks us to extend this search deeper, to times like the Devonian period, when the Earth was a mosaic of seas and early forests, looking for signs of something crafted by intelligent hands. Another tool in this quest is satellite imagery, which captures the Earth from above like a painter sketching a grand landscape. Satellites equipped with advanced sensors can detect subtle differences in vegetation, soil, or heat, hinting at buried structures. For example, in Egypt, satellites revealed the outlines of lost pyramids, their shapes hidden under sand. If a Silurian civilization built cities or monuments, their faint traces might still linger, visible only from the sky. Scientists analyze these images with computers, sifting through data to find patterns that don't align with nature's handiwork. The Silurian Hypothesis suggests we turn these eyes to older landscapes, perhaps to ancient coastlines from 430 million years ago, searching for shapes that whisper of a forgotten society. Chemical analysis, too, plays a starring role in this scientific symphony. Mass spectrometry, a technique that sorts atoms by their weight, allows researchers to probe the composition of rocks or sediments with exquisite precision. Picture a scientist in a lab, feeding a tiny sample of rock into a machine that hums softly, revealing the presence of unusual elements or isotopes. If a civilization used metals or synthetic materials, their chemical fingerprints could remain, like a signature faded but not erased. Scientists have found such anomalies in modern sediments, like traces of lead from industrial pollution. The Silurian Hypothesis encourages us to look for similar signals in ancient layers, perhaps from the Silurian period, where a spike in rare metals might suggest a civilization's industry, its tools or machines leaving a mark in the Earth's chemistry. Seismic imaging is another marvel, like listening to the Earth's heartbeat. By sending sound waves deep into the ground, scientists can map hidden structures, from ancient faults to buried craters. This technique has revealed the Chicxulub crater, the scar left by the asteroid that ended the dinosaurs 66 million years ago. If a Silurian civilization's remnants were buried by a cataclysm, seismic imaging could detect their outlines, perhaps a cluster of unnatural shapes beneath a mountain or plain. Researchers use this to study the Earth's crust, mapping layers from hundreds of millions of years ago. The Silurian Hypothesis invites us to imagine finding something unexpected, a grid of streets, or a foundation hidden in these ancient depths, a clue to a world long gone. The power of these tools lies in their ability to see what the naked eye cannot. Infrared spectroscopy, for instance, detects the unique light signatures of materials, like a fingerprint glowing in the dark. Scientists use it to analyze rocks or artifacts, identifying compounds that don't belong. If a civilization crafted materials like ceramics or alloys, their signatures might linger in ancient sediments. Researchers have used this technique to study meteorites, finding traces of organic compounds from space. The Silurian Hypothesis asks us to apply this to Earth's rocks, perhaps from the Devonian period, looking for materials that suggest a civilization's hand may be a fragment of something forged. Its light signature, a whisper from a lost era. Computer modeling adds another layer to this search, like a storyteller weaving a tale from fragments. Scientists use simulations to predict how a civilization's artifacts might survive over millions of years. For example, they model how metals corrode or plastics degrade, estimating what traces might remain. Modern plastics break down into microparticles, leaving a detectable layer in sediments. If a Silurian civilization used similar materials, their remnants could be scattered in ancient layers, like dust settled after a storm. These models guide researchers to the most promising sites, from ancient seabeds to eroded hills, where a civilization's legacy might hide. It's a process that feels like piecing together a mosaic, each fragment a clue to a larger picture. Drones have become a new ally in this quest, soaring over landscapes to capture images and data with precision. Equipped with sensors, they can detect magnetic or thermal anomalies, hinting at buried structures. In archaeology, drones have revealed lost cities in jungles, their outlines hidden under vegetation. The Silurian Hypothesis suggests we use these tools to explore older terrains, perhaps the rocky outcrops of the Silurian period, where a civilization's ruins might lie buried. Imagine a drone gliding over a barren plain, its sensors picking up a faint signal, a grid, or a shape that doesn't belong, suggesting a city lost to time, its story waiting to be told. Another cutting-edge tool is laser scanning, or LiDAR, which uses pulses of light to map the Earth's surface in 3 dimensions. LiDAR has uncovered hidden temples in dense forests, stripping away vegetation to reveal stone beneath. If a Silurian civilization built structures, their remnants might be hidden under layers of sediment or rock, visible only to LiDAR's precise gaze. Scientists use this to study ancient landscapes, from river valleys to coastal plains, searching for anomalies that stand out. The Silurian Hypothesis encourages us to apply this to older periods, like 400 million years ago, when the Earth was a patchwork of shallow seas, looking for traces of something built, not grown. The integration of these tools creates a powerful toolkit, like a set of keys unlocking different doors. Scientists combine satellite imagery with ground-penetrating radar, cross-referencing chemical data with seismic maps to build a fuller picture of the past. They've used this approach to uncover ancient human settlements, like the cities of Mesopotamia, buried under centuries of sand. The Silurian Hypothesis asks us to extend this to deeper time, to periods like the Silurian or Devonian, where a civilization's traces might be faint but detectable. It's like searching for a single star in a daytime sky, each tool a lens bringing the past into focus. These technologies also rely on collaboration, with scientists from different fields working together like musicians in an orchestra. Geologists, chemists, and physicists share data, using supercomputers to analyze vast datasets. For example, isotopic analysis might reveal a spike in carbon from an ancient layer, while seismic imaging maps a buried structure nearby. Together, these clues could suggest a civilization's presence, its industry or architecture, leaving a mark. The Silurian Hypothesis thrives on this interdisciplinary approach, encouraging scientists to combine their tools to uncover the unexpected, like a melody hidden in the noise of time. The challenge of this search lies in the Earth's vastness and the passage of millions of years. Most traces of a civilization would be eroded, subducted, or buried beyond reach. Yet some environments, like stable ocean basins or ancient caves, act as natural archives. Scientists use their tools to target these places, drilling cores or scanning surfaces to find anomalies. They found traces of ancient climates in such sites, like shifts in oxygen isotopes from 400 million years ago, tied to the rise of early plants. The Silurian Hypothesis asks us to look for something more, a signal that doesn't fit, like a piece of metal or a synthetic compound preserved in a forgotten corner of the Earth. These tools also reveal the Earth's dynamic nature, its surface constantly reshaped by wind, water, and tectonic shifts. Scientists use geophysical surveys to map these changes, tracking how ancient landscapes have moved over time. If a civilization existed, its cities might have been on a coastline now buried under a mountain. Tools like magnetometry, which detects changes in the Earth's magnetic field, can reveal buried structures, as seen in archaeological sites like Pompeii. The Silurian Hypothesis suggests we apply these to older rocks, perhaps from the Silurian period, searching for magnetic anomalies that could hint at a civilization's works, like a shadow cast across time. The precision of these tools is astonishing, like reading a book written in whispers. Mass spectrometry can detect isotopic ratios to parts per billion, revealing the faintest traces of ancient activity. Scientists have used this to study rocks from the Cambrian period, about 540 million years ago, finding clues to the explosion of life. If a Silurian civilization altered its environment, its chemical signature might be just as subtle, a faint shift in carbon or nitrogen preserved in a rock. The Silurian Hypothesis encourages us to keep searching, using every tool to listen for these whispers, each one a potential clue to a world that might have been. These technologies also push the boundaries of what's possible, driving innovation as scientists seek new ways to probe the past. For example, advances in machine learning help analyze vast data sets, spotting patterns that human eyes might miss. In archaeology, algorithms have identified hidden structures in satellite images, like lost villages in the Amazon. The Silurian Hypothesis suggests we turn these tools to deeper time, training computers to search for anomalies in ancient rocks or sediments. It's like giving the Earth a voice, letting it tell its story through the data we collect, each discovery a step closer to understanding its hidden chapters. As we linger in this world of scientific tools, the Silurian Hypothesis reminds us that the past is never truly lost, only waiting for the right light to shine upon it. Scientists continue to refine their methods, combining radar, satellites, and chemical analysis to uncover the Earth's secrets. They study rocks from every corner of the globe, from ancient seabeds to frozen peaks, searching for that one anomaly that could rewrite history. For now, these tools are like lanterns, casting a gentle glow on the shadows of the past, revealing a world that might hold traces of a civilization long forgotten. From this realm of glowing instruments, let's drift gently forward to a broader horizon, where the Earth's story meets the cosmos. Imagine looking up at the stars, each one a possible home to other civilizations, their traces perhaps left not just on Earth, but across the universe. We'll explore how the Silurian Hypothesis connects to the search for extraterrestrial life, its questions echoing beyond our planet, into the vast museum of the stars. Welcome back to Sparx Science for Sleep, where we glide through the Earth's ancient mysteries, each story a gentle whisper guiding us toward rest. As we step away from the glowing lanterns of modern science, illuminating the hidden corners of our planet's past, we now lift our gaze to the stars. Picture the cosmos as a vast museum, its galleries filled with the relics of countless worlds, each star a keeper of secrets. The Silurian Hypothesis, which has led us through the Earth's rocks, fossils, and oceans, now stretches beyond our planet, connecting to the grand question of extraterrestrial civilizations. Could beings from another world have left traces on Earth, perhaps millions of years ago? Let's take a soft breath and drift into this celestial tale, where the universe itself becomes a canvas of possibilities. The search for extraterrestrial life has long captivated scientists, a quest embodied in the SETI program, which stands for Search for Extraterrestrial Intelligence. SETI researchers use powerful telescopes to scan the skies, listening for radio signals that might carry the voice of a distant civilization. Imagine a telescope pointed at a faraway star, its dish like an ear turned toward the heavens, waiting for a whisper from across the galaxy. If an alien civilization visited Earth long ago, as the Silurian Hypothesis might suggest, they could have left traces, perhaps a fragment of technology, or a signal embedded in the rock record. Scientists listen for these signals not just from space but also in the Earth's ancient layers, wondering if a visitor from the stars might have walked our planet during the Silurian period, 430 million years ago. One idea in this cosmic search is the concept of a Dyson sphere, a theoretical structure built by an advanced civilization to capture a star's energy. Picture a star wrapped in a delicate lattice of solar panels, like a flower encased in a shimmering web. Such a structure would emit unique infrared signals, detectable by telescopes like those used by SETI. If an alien civilization built a Dyson sphere, or similar technology near Earth millions of years ago, fragments of it might have fallen to our planet, buried in sediments, or preserved in rocks. Scientists study meteorites and ancient deposits for unusual materials, like alloys or isotopes not found in nature, that could hint at such extraterrestrial visitors. The Silurian Hypothesis asks us to consider if these traces, from a civilization not of Earth, might lie hidden in our planet's deep past. Meteorites themselves are cosmic messengers, carrying clues from beyond our world. Scientists analyze these space rocks, which have fallen to Earth for billions of years, to understand the chemistry of the solar system. Some meteorites contain amino acids, the building blocks of life, suggesting that the seeds of biology might have come from space. If an alien civilization visited Earth, they could have left behind materials, perhaps a piece of a spacecraft or a tool now mistaken for a meteorite. Researchers use mass spectrometry to probe these rocks, looking for elements or compounds that don't match Earth's natural chemistry. Imagine a fragment of metal, glowing faintly in a lab, its composition whispering of a technology from another star, buried in a layer from the Devonian period. The Silurian Hypothesis also connects to the idea of panspermia, the theory that life might have spread across the cosmos like seeds on the wind. If an alien civilization seeded Earth with life or technology millions of years ago, their influence could be embedded in the fossil record or chemical signatures. Scientists study ancient rocks for signs of organic compounds or unusual isotopic ratios, like those found in meteorites from Mars, which hint at the possibility of microbial life. If a Silurian civilization was extraterrestrial in origin, its traces might resemble these cosmic signatures, perhaps a layer of sediment rich in strange carbon compounds, preserved from a time when Earth was a lush world of shallow seas and early forests. Another avenue of exploration is the search for megastructures, massive constructions built by advanced civilizations. Beyond Dyson spheres, scientists imagine structures like orbital habitats or vast communication arrays, their remnants potentially scattered across planets. If such a civilization visited Earth, their debris might have settled into the ocean or been buried by tectonic shifts. Researchers use tools like ground-penetrating radar to search for anomalies in ancient layers, hoping to find shapes or materials that suggest artificial origins. Picture a fragment of a crystalline lattice buried in a Silurian seabed, its edges too perfect to be natural, a relic of a visitor from the stars waiting to be uncovered. The study of exoplanets, planets orbiting distant stars, also informs this search. Telescopes like the James Webb Space Telescope scan these worlds for signs of life, such as gases like oxygen or methane in their atmospheres. If an alien civilization visited Earth long ago, they might have come from such a planet, leaving traces of their technology or biology. Scientists analyze Earth's ancient rocks for similar biosignatures, wondering if a spike in methane from 400 million years ago could indicate not just microbial life, but an extraterrestrial presence. The Silurian Hypothesis expands this idea, suggesting that the Earth itself might be an exoplanet in the eyes of another civilization, its surface a canvas for their explorations. SETI researchers also look for technosignatures, signals of advanced technology, like radio waves or laser pulses. If an alien civilization left a beacon or device on Earth millions of years ago, it might have left a faint signal in the geological record. Scientists study ancient rocks for electromagnetic anomalies, perhaps a trace of radiation or magnetic disturbance that could suggest a technological artifact. Imagine a tiny device, buried in a layer of Devonian rock, its signal long faded, but its materials still distinct, a whisper from a civilization that crossed the stars. The Silurian Hypothesis encourages us to see Earth as part of this cosmic search, a planet that might hold relics of visitors from beyond. The possibility of extraterrestrial visitors also raises questions about their motives. Scientists speculate that an advanced civilization might have explored Earth for resources, like minerals or water, leaving behind mining sites or processing facilities. These could appear as unusual concentrations of metals in ancient rocks, similar to the iridium layer from the Chicxulub asteroid 66 million years ago. Researchers use chemical analysis to probe such anomalies, looking for patterns that don't align with natural processes. If a Silurian civilization was alien, its mines or factories might have left a chemical footprint, like a melody played on an alien instrument, preserved in the Earth's deep layers. The search for extraterrestrial traces also draws on the study of astrobiology, which explores the conditions for life across the universe. Scientists look for environments on Earth, like ancient hot springs or ocean vents, that might have hosted alien life or technology. These sites, rich in minerals and energy, could have been ideal for an extraterrestrial civilization to establish a base. Researchers study sediments from such places, like those from the Silurian period, for signs of unusual chemistry or structures. Imagine a fossilized fragment, not of bone but of a material forged in a distant star. Its presence, a hint of a civilization that saw Earth as a temporary home. The cosmos is vast, with billions of stars and planets, each a potential cradle for life. The Drake equation, a formula used by SETI, estimates the likelihood of communicative civilizations in our galaxy, factoring in the number of stars, planets, and the chances of intelligent life. If even a fraction of these civilizations explored space, some might have reached Earth millions of years ago. The Silurian Hypothesis asks us to consider that our planet could have been a waypoint, its rocks holding relics of their visit. Scientists search for these relics in meteorites, sediments, or even ancient ice, looking for materials that don't belong, like a piece of technology from a faraway world. The search for extraterrestrial traces also involves studying the Earth's magnetic field, which can preserve anomalies from ancient events. If an alien civilization used electromagnetic technology, it might have left a faint signature in the rock record, like a ripple in a still pond. Scientists use magnetometry to detect such signals, as seen in archaeological sites where ancient fires left magnetic traces. The Silurian Hypothesis suggests we apply this to older layers, perhaps from 400 million years ago, looking for disturbances that could indicate a technological presence, a whisper of a civilization that crossed the stars to reach our shores. The idea of alien visitors also connects to the study of cosmic impacts, which could have brought extraterrestrial materials to Earth. Scientists analyze meteorites for isotopes or compounds not found on our planet, like those in the Murchison meteorite, which contains organic molecules from space. If an alien civilization left debris on Earth, it might resemble these materials, perhaps a fragment of a spacecraft buried in a Silurian sediment. Researchers use advanced spectroscopy to probe these samples, searching for signatures that stand out, like a single bright star in a dark sky, hinting at a technology from beyond. The Silurian Hypothesis also draws on the concept of directed panspermia, where an advanced civilization might have intentionally seeded Earth with life or technology. Scientists explore this idea by studying ancient rocks for signs of complex organic molecules or structures that suggest artificial origins. If such a civilization visited Earth, their influence could be woven into the planet's early biology or chemistry, preserved in layers from the Devonian or earlier. Imagine a trace of synthetic carbon locked in a rock, its structure too regular to be natural, a sign of a civilization that shaped our world long before humans. The search for extraterrestrial traces is not just about finding artifacts, it's about understanding our place in the cosmos. Scientists use telescopes, spectrometers, and computer models to probe the universe, looking for signs of life or technology. If a Silurian civilization was alien, its remnants might be scattered across Earth, in sediments, rocks, or even the atmosphere. Researchers study ancient air bubbles, trapped in minerals, for gases that could suggest an alien presence, like a spike in xenon from a long-gone reactor. The Silurian Hypothesis invites us to see Earth as part of a larger story, a planet that might have been touched by the stars. This cosmic perspective also draws on the Fermi paradox, the question of why we haven't found clear signs of extraterrestrial life despite the universe's vastness. If an alien civilization visited Earth millions of years ago, their traces might be faint, eroded by time, or buried deep. Scientists search for these traces using every tool at their disposal, from radar to chemical analysis, hoping to find a clue that changes everything. The Silurian Hypothesis suggests that Earth itself might hold the answer, its rocks and sediments, a gallery of cosmic relics, waiting for us to explore. As we linger in this vast museum of the stars, the Silurian Hypothesis reminds us that the universe is full of possibilities, each one a story waiting to be told. Scientists continue to search, their telescopes and labs like windows to the cosmos, seeking signs of civilizations that might have visited our world. For now, these traces remain whispers, faint but tantalizing, inviting us to wonder about the Earth's place in the grand tapestry of the universe. From this celestial gallery, let's drift gently forward to a deeper question, one that touches the heart of our journey. Picture the Earth as a single star in the cosmic night, its story intertwined with our own. We'll explore what it means to be human in a universe that might have hosted other civilizations, their legacy a quiet hum in the vastness of time, guiding us toward a moment of reflection. Welcome back to Sparx Science for Sleep, where we wander through the gentle mysteries of the cosmos, each tale a soft thread in the tapestry of time. As we drift from the vast museum of the stars, where the Silurian Hypothesis stretched our gaze to the possibility of extraterrestrial visitors, we now turn inward to a quieter, more reflective question. Picture the Earth as a single, shimmering light in the cosmic night, its surface alive with stories of life and perhaps civilizations long gone. The Silurian Hypothesis invites us to ponder our place in this grand narrative, asking what it means to be human if others came before us, their legacies hidden in the Earth's ancient layers. Let's take a soft breath and slip into this moment of contemplation, where the universe's vastness meets the quiet wonder of our existence. The Silurian Hypothesis challenges us to rethink humanity's role in the Earth's long history, like a single page in a book that spans billions of years. If a civilization thrived millions of years ago, perhaps in the Silurian period, 430 million years ago, it would mean we are not the first to shape this planet. Scientists explore this idea not just to find evidence, but to understand what it says about our own journey. Imagine a society with its own dreams, technologies, and stories, rising and falling long before humans walked the Earth. Their existence would suggest that civilizations are fleeting, like fireflies flickering in the night, each one bright but brief against the vast backdrop of time. This thought invites a sense of humility, reminding us that our cities, our machines, our very presence might one day be reduced to whispers in the rock. Civilizations, whether human or otherwise, leave marks on the planet, but time is a relentless eraser. Scientists study our own impact cities, sprawling across continents, emissions altering the air to predict how long our traces will last. In a million years, our skyscrapers might crumble to dust, our plastics break into microscopic grains, our chemical signatures fade into the Earth's layers. If a Silurian civilization existed, its legacy would face the same fate. Its cities buried, its tools eroded, its story preserved only in the faintest clues. This fragility of civilization suggests that life's achievements, no matter how grand, are temporary, like waves smoothing a sandcastle into the shore. The Silurian Hypothesis asks us to consider how we might leave a legacy that endures, or if our story too will fade into the planet's quiet memory. The study of ancient climates offers a lens into this question. Scientists analyze rocks and sediments from periods like the Devonian, about 400 million years ago, to understand how the Earth's environment has changed. A civilization's activities mining, burning fuels, or building could have altered the climate, leaving traces like spikes in carbon dioxide or methane. Our own civilization has caused such changes, warming the planet with greenhouse gases. If a Silurian civilization did the same, its impact might be detectable in ancient sediments, like a faint echo of industry. This idea reminds us that our actions ripple through time, shaping the Earth's future just as past civilizations might have shaped its past. their influence lingering like a soft hum in the planet's history. The transience of civilizations also raises questions about their rise and fall. Scientists study the history of life to understand why some species thrive while others vanish. The Silurian Hypothesis suggests that an intelligent species could have evolved, built a society, and disappeared, perhaps due to a cataclysm like an asteroid or a self-inflicted disaster like climate change. Our own history shows how fragile societies can be. Ancient cultures like the Maya or the Indus Valley collapsed due to environmental shifts or resource depletion. If a Silurian civilization faced similar challenges, its story would be a cautionary tale, urging us to tread lightly on the Earth, to nurture its balance rather than disrupt it. This reflection also touches on the concept of deep time, the vast expanse of Earth's history that dwarfs human existence. The planet is 4.6 billion years old, a timeline so immense it's like a river stretching beyond the horizon. Scientists use radiometric dating to measure this time, tracking the decay of elements like uranium in ancient rocks. If a civilization existed 400 million years ago, its traces would be scattered across this vast timeline, hidden in layers we've only begun to explore. The Silurian Hypothesis encourages us to see ourselves as a brief moment in this continuum, a single note in a symphony that has played for eons, each civilization adding its own melody before fading into silence. The possibility of a prior civilization also sparks questions about intelligence itself. Scientists study the evolution of complex behaviors in animals, from the problem-solving of octopuses to the tool use of early humans, to understand how intelligence arises. If a Silurian civilization existed, it might have emerged from a species unlike any we know, perhaps a reptile, a cephalopod, or something entirely alien. Their intelligence could have shaped technologies or cultures we can't imagine, leaving traces that don't fit our expectations. The Silurian Hypothesis asks us to broaden our view of intelligence, to consider that the Earth might have hosted minds as complex as our own, their thoughts and creations now lost to time's gentle erosion. The search for such a civilization also highlights the limits of our knowledge. Scientists rely on evidence, fossils, isotopes, structures, but the Earth's surface is constantly reshaped by tectonic plates, erosion, and climate. Most of the planet's history is erased, like a chalkboard wiped clean. If a Silurian civilization existed, its evidence might be so faint that our current tools can't detect it. This uncertainty teaches us humility, a reminder that our understanding of the Earth is incomplete, like a book with missing chapters. Yet it also inspires curiosity, driving scientists to refine their methods, to search deeper, to listen for the faintest whispers of a lost world. This idea of transience extends to our own civilization's legacy. Scientists predict that in 100 million years, most traces of humanity, our cities, roads, and machines will be gone, ground down by the Earth's relentless cycles. Only the most durable materials, like certain metals or ceramics, might survive, buried in sediments or locked in rock. If a Silurian civilization left such materials, they could be waiting in layers from 400 million years ago, perhaps in a quiet seabed or a mountain's core. The Silurian Hypothesis asks us to consider what we want our legacy to be, how we might leave a mark that speaks of care rather than destruction, a message for the future written in the Earth's enduring stone. The fragility of civilizations also connects to the concept of sustainability. Scientists study ancient ecosystems to understand how life adapts to change. The Devonian period, for instance, saw the rise of early forests, which transformed the Earth's atmosphere by absorbing carbon dioxide. If a Silurian civilization disrupted its environment, perhaps by overusing resources or polluting, it could have triggered its own collapse, leaving only scattered clues. Our own civilization faces similar risks, with climate change and resource depletion threatening our future. The Silurian Hypothesis offers a mirror, reflecting our own choices and urging us to build a society that harmonizes with the Earth, ensuring our story endures longer than a fleeting moment. This reflection also draws on the idea of cultural evolution, how societies develop and pass down knowledge. If a Silurian civilization existed, it might have had its own language, art, or science, now lost to time. Scientists study ancient human cultures, like the cave paintings of Lascaux, to understand how knowledge is preserved. If a Silurian civilization had similar expressions, they might have left symbols or structures, perhaps etched in stone or buried in sediment. The Silurian Hypothesis encourages us to look for such signs, to imagine a civilization's story told through its creations, like a poem whispered to the ages, its meaning fading but not entirely gone. The question of prior civilizations also touches on the idea of planetary stewardship. Scientists study the Earth's systems, its climate, oceans, and biosphere to understand how they interact. A civilization that altered these systems, perhaps through agriculture or industry, would leave traces in the geological record, like the carbon spikes we see in modern sediments. If a Silurian civilization existed, its impact might be preserved in rocks from 400 million years ago, a subtle shift in chemistry or structure. This idea reminds us that we, too, are shaping the Earth's future, our actions leaving a legacy for those who come after, a story written in the planet's layers. The Silurian Hypothesis also connects to the broader question of life's purpose. Scientists explore the origins of life, from simple microbes to complex societies, to understand why intelligence evolves. If another civilization rose and fell on Earth, it suggests that intelligence is a recurring theme, like a melody played again and again. This perspective makes our own existence feel both small and profound, a single verse in a cosmic song. The Silurian Hypothesis asks us to consider what we do with our moment, how we contribute to the Earth's story, and whether our legacy will be one of creation or destruction, a light that shines or fades. The study of mass extinctions, like the one that ended the Permian period 250 million years ago, offers another lens. These events reshaped life, wiping out entire ecosystems but paving the way for new ones. If a Silurian civilization was erased by such a cataclysm, its traces might be subtle, a layer of unusual sediment, or a fossilized artifact. Scientists search for these clues, using tools like isotopic analysis to detect anomalies. The Silurian Hypothesis suggests that our own civilization could face a similar fate, urging us to learn from the past, to build a future that withstands the test of time, a story that endures in the Earth's memory. This reflection also touches on the concept of cosmic perspective, the idea that Earth is just one planet in a vast universe. Scientists estimate there are billions of planets in our galaxy alone, many potentially habitable. If a Silurian civilization was extraterrestrial, as we explored in the last chapter, its presence would place Earth in a larger cosmic narrative. This perspective humbles us, reminding us that our time here is brief, like a star's flicker in the night. The Silurian Hypothesis asks us to see ourselves as part of this larger story, a civilization among many, each leaving its mark on the universe's vast canvas. As we linger in this moment of contemplation, the Silurian Hypothesis offers a final lesson: the importance of curiosity. Scientists pursue these questions not just for answers, but for the joy of exploration, the wonder of uncovering the unknown. Whether a Silurian civilization existed or not, the act of searching expands our understanding, like a lantern casting light into the dark. It reminds us that our place in the universe is defined not just by what we know, but by what we seek, the questions we ask, and the stories we tell. The Earth's history, with its layers of rock, fossils, and chemistry, is a testament to this curiosity, a record of life's endless quest to understand itself. From this quiet reflection on our place in the Earth's story, let's glide gently toward the end of our journey, where the stars themselves become our companions. Picture a night sky, vast and serene, each star a story waiting to be told. We'll weave together the threads of this tale, finding peace in the beauty of the unknown, as we prepare to rest under the cosmic canopy of the universe. Welcome back to Sparx Science for Sleep, where we've wandered through the Earth's ancient tales, each one a gentle thread weaving us toward rest. As we drift from the quiet reflection of our place in the cosmic story, where the Silurian Hypothesis asked us to ponder humanity's fleeting moment in the universe's vast narrative, we now arrive at the close of our journey. Picture a night sky, vast and serene, its stars twinkling like stories waiting to be told, each one a whisper from the past or a promise of the future. The Silurian Hypothesis has carried us through the Earth's rocks, fossils, oceans, and even to the stars, and now it invites us to pause, to let the beauty of these mysteries cradle us as we prepare to rest. Let's take a soft breath and settle into this final chapter, where the wonder of science and the calm of the night weave together under a canopy of stars. Our journey began with the Earth as a book, its pages written in stone, holding secrets of civilizations that might have walked this planet millions of years ago. The Silurian Hypothesis opened a door to this possibility, suggesting that intelligent beings, human, alien, or something entirely unknown, could have shaped the Earth long before us. We explored the layers of rock, like ancient manuscripts, where geologists search for chemical traces or unusual minerals that might hint at a forgotten society. These rocks, formed over billions of years, are the Earth's memory, preserving the faintest echoes of its past. Scientists use radiometric dating, measuring the decay of elements like uranium, to read this timeline, each layer a chapter in a story that stretches back to the planet's birth 4.6 billion years ago. From there, we wandered into the gallery of fossils, where the bones and shells of ancient creatures tell tales of life's evolution. Paleontologists study these relics, like the trilobites of the Silurian period, 430 million years ago, to understand the diversity of life. The Silurian Hypothesis asked us to look for something more fossils that might not be natural, perhaps a fragment of a tool or a structure too precise to be mere chance. These fossils, locked in stone, are like photographs of a world long gone, their shapes a puzzle that scientists piece together with microscopes and patience. The idea that a civilization's creations could be among them adds a layer of wonder, like finding a hidden verse in a familiar poem. We then delved into the Earth's chemistry, where isotopes sing a subtle song of the past. Geochemists analyze these atomic notes, looking for anomalies, spikes in carbon, sulfur, or metals that could suggest industrial activity from a lost civilization. Modern human activity leaves such marks, like the carbon dioxide from our factories, and the Silurian Hypothesis wonders if a similar signature might linger in rocks from 400 million years ago. Scientists use tools like mass spectrometry to detect these traces, their precision like a whisper heard across eons. This chemical record, woven into the Earth's crust, is a testament to the planet's ability to hold on to its stories, even as time tries to erase them. The Earth's cataclysms came next, painting a picture of a planet both destructive and creative. Asteroid impacts, like the Chicxulub event 66 million years ago, and volcanic eruptions, like the Siberian Traps 250 million years ago, reshaped the world, wiping out life but also preserving it in layers of ash and sediment. The Silurian Hypothesis suggests that a civilization could have been erased by such an event, its cities buried or its tools locked in stone. Scientists study these layers for signs of something unnatural, a shard of metal, a chemical anomaly using seismic imaging and core samples to probe the past. These cataclysms, like the Earth's dramatic brushstrokes, remind us that the planet is both a destroyer and a keeper of secrets. In the ocean's depths, we found a silent archive, where sediments pile up like pages in a library. Marine sediments, formed from the slow fall of particles, hold clues to ancient climates and ecosystems. Scientists drill into the seafloor, retrieving cores that stretch back hundreds of millions of years, searching for traces of a civilization, perhaps a spike in heavy metals or synthetic compounds. The Silurian Hypothesis asks us to imagine a city's debris sinking into the mud, preserved in the quiet dark of the ocean. These sediments, studied with tools like spectroscopy, offer a glimpse into a world of shallow seas and early life, where a civilization's legacy might lie hidden, like a treasure in a sunken chest. The tools of modern science then lit our path, like lanterns in the dark. Ground-penetrating radar, satellite imagery, and laser scanning allow scientists to see beyond the surface, mapping buried structures or chemical anomalies. These technologies, used to uncover ancient human sites like lost pyramids, could reveal a Silurian civilization's remnants, a wall, a road, or a material too regular to be natural. The Silurian Hypothesis thrives on this innovation, encouraging scientists to combine their tools, from isotopic analysis to computer modeling, to search for clues in rocks from 400 million years ago. Each tool is a key, unlocking a piece of the Earth's vast puzzle, bringing us closer to its hidden truths. Our gaze then turned to the stars, where the Silurian Hypothesis connected to the search for extraterrestrial life. SETI researchers scanned the cosmos for signals like radio waves or infrared patterns that might indicate an alien civilization. The idea that such a civilization visited Earth millions of years ago, leaving traces in our rocks or sediments, expands the hypothesis into a cosmic question. Scientists study meteorites for unusual materials like amino acids or alloys that could suggest an extraterrestrial presence. The concept of a Dyson sphere, a structure harnessing a star's energy, or panspermia, the seeding of life across planets, adds a layer of wonder, suggesting that Earth might be part of a larger galactic story, its surface a canvas for cosmic visitors. In our last reflection, we pondered our place in this grand narrative, asking what it means to be human if others came before us. The Silurian Hypothesis suggests that civilizations are fleeting, their legacies fragile against the vastness of time. Scientists study our own impact, climate change, pollution, urbanization, to predict how long our traces will last, wondering if a Silurian civilization left similar marks. This perspective humbles us, reminding us that we are a brief moment in the Earth's 4.6 billion-year history, a single note in a cosmic symphony. It urges us to act with care, to leave a legacy that speaks of harmony rather than destruction, a story that endures in the planet's quiet layers. Now, as we close this journey, the Silurian Hypothesis leaves us with a sense of wonder, a reminder that the Earth is a keeper of secrets we may never fully unravel. The science behind this idea, geology, paleontology, chemistry, and astrobiology, shows us how deeply connected we are to the planet's past. Each rock, each fossil, each chemical trace is a piece of a larger story, one that stretches from the Silurian seas to the stars above. Scientists continue to search, driven by curiosity, their tools and questions lighting the way like stars in the night. Whether a Silurian civilization existed or not, the act of exploring these possibilities expands our understanding, like a book opening to reveal new pages. The beauty of this journey lies in its mystery, the idea that the Earth holds stories we've yet to hear. The Silurian Hypothesis isn't just about finding a lost civilization, it's about embracing the unknown, letting the questions themselves be a source of calm. Scientists study the past, not for certainty, but for the joy of discovery, each clue a step toward understanding our world. The rocks from 400 million years ago, the fossils of ancient creatures, the sediments of the deep sea, all are part of a narrative that includes us, a story that began long before humans and will continue long after. This perspective is like a gentle tide, washing over us with a sense of connection to something vast and enduring. The Earth's history is a cycle of creation and loss, of moments that shine and then fade. The Silurian Hypothesis reminds us that our time here is brief, a fleeting spark in the planet's long tale. Scientists study this tale through layers of rock, chemical signatures, and cosmic clues, each discovery a thread in the tapestry of life. If a civilization came before us, its story might be hidden in a single grain of sediment, a whisper of isotopes, or a fossil too strange to explain. This possibility doesn't demand answers. It invites wonder, a quiet appreciation for the Earth's depth and mystery, like a starlit sky that stretches beyond our reach. As we rest under this cosmic canopy, the stars above seem to pulse with stories, each one a chapter in the universe's book. The Silurian Hypothesis has shown us how science can weave these stories, from the Earth's ancient rocks to the possibility of alien visitors. It's a reminder that curiosity is a gift, driving us to ask questions even when the answers are uncertain. Scientists will keep searching, their tools and minds attuned to the faintest signals, like listeners waiting for a distant melody. For now, the Earth holds its secrets close, its layers a quiet archive of all that has been and all that might be. This journey has been a tapestry of science and wonder, each thread a story of the Earth's past. We've walked through its rocks, listened to its fossils, traced its chemistry, and gazed at its stars, all through the lens of the Silurian Hypothesis. The idea that we might not be the first to call this planet home is like a soft breeze, stirring our thoughts without disturbing the calm. It reminds us that the Earth is a living story, its pages written in stone, water, and light, and we are but one chapter, bright and brief. As you lie here, let the beauty of this idea settle over you, a gentle reminder that the universe is vast, and we are part of its endless tale. The Silurian Hypothesis also teaches us to look forward, to consider the legacy we leave. Scientists study our impact on the Earth, our cities, our pollution, our changes to the climate, to understand how future generations might find us. If a Silurian civilization existed, its traces are faint, a lesson in the fragility of existence. Our own story could follow the same path, our achievements fading unless we act with care. This thought is not heavy but soothing, a call to live in harmony with the planet, to write a chapter that speaks of balance and beauty, preserved for those who come after. As we close this journey, let's linger on the stars, each one a possibility, a story yet to be told. The Silurian Hypothesis has guided us through the Earth's depths and beyond, showing us how science can illuminate the unknown. Whether a civilization came before us or not, the search itself is a gift, a way to connect with the planet's past and the universe's vastness. Scientists will continue to explore, their curiosity a light in the dark, uncovering clues that bring us closer to the truth. For now, the Earth's secrets remain, like stars hidden by the dawn, waiting for the next explorer to find them. If you've enjoyed this journey, consider leaving a comment to share where you're listening from or what time it is in your corner of the night. Your thoughts are like stars, adding to the constellation of this story. As you drift towards sleep, let the wonder of the Silurian Hypothesis carry you, its questions a gentle lullaby. The Earth is a keeper of mysteries, and tonight we've wandered through its tales, from ancient rocks to cosmic possibilities. Sleep well, and may your dreams be filled with the quiet beauty of the universe's endless stories.